Yes, I see it.
Okay, wonderful. My name is Iman Kabazian, and I have a passion for building games. I'm a former technical director at Disney, and I've built games that drove over $80 million in revenue. And today I'm here to tell you about a game framework that me and my good friend and colleague, Dan Parker, built uh, with Akka.net and inspired by Akka.net, really. And it's called Game Plumbing Framework, or GPF. Today I'm going to share what we built, describe the architecture, and talk about exactly how GPF accelerates development velocity for Unity developers building a game in Unity. To understand the problem GPF solves, we have to put ourselves in a Unity game developer's shoes. Unity game developers want to create fun games, and these games need a safe player state. They're often multiplayer, so they need backends, but building these backends can often be anything but fun, because if you hire a backend programmer, they're usually pretty rare, hard to find, pretty expensive. I'm sure we have some expensive backend programmers on this call. Um, you have to build for scalability, and this is something a lot of people struggle with. Fortunately, Akka.net helps with that. Um, it's been my experience that game logic usually has to be scattered throughout the stack, or ends up scattered throughout the stack, because you have to put game logic on the front end so your game is responsive, but then you have to put it on the back end so your game is authoritative server, so people can't cheat, and it ends up kind of reflecting itself in the networking layer as well as in the database layer sometimes. And on top of all of these obstacles, today's games are much more complicated because users are demanding multiplayer everything. So you got to keep everything synced up. So the way Game Plumbing Framework solves these problems is we try to abstract away the complexities for Unity developers. So we empower them to easily customize backends and integrate with their data. So this is kind of the only solution where a Unity developer is going to build something, and it's going to do two things at once. One, it's going to serve as game logic for the client, and two, it's going to be deployed to the back end and serve as game logic on the back end. So within the development environment they're used to, they're actually creating and deploying back-end logic kind of behind the scenes. We also provide tightly integrated systems that let them take the data that is kind of buried within these back-end abstractions, and make it really easy to hook that data up to UI. So to help further explain the origins of the framework and the value it brings, I will take you back to the events that kind of triggered the creation of Game Plumbing Framework. Back in 2019, I was hired to architect a massively multiplayer map system for a Unity game. And that team wanted a backend that ran in C# because Unity runs off of C#, and they wanted their developers to go full stack. And this is kind of a goal that I've always thought would be really helpful, but few teams have been able to really pull it off. So I was looking for, first I started looking at stateless backends, because scaling stateless backends was kind of my specialty, but it became clear that because of the connected nature, it would be super expensive to scale a stateless backend. So that's when I found Akka.net, and it was just the perfect solution. I did the boot camps, I read the ebook, I recommended it to the team, and I was really inspired by how thoughtful the code base was and how it solved some really hard problems and kind of put us in a position to win this battle in a way that scales, and in a way where we're not painting ourselves into a corner. And I watched the team work with it, and at first they seemed happy because the MMO problem was like this impossible to solve problem, and now they had a path. But at the same time, I saw them struggle with, their whole goal was to share code on the front end and the back end. And they, when a backend engineer got in there and ran his tests and changed that code up, he would break the front end engineer And when a front end engineer would try to get into that shared piece of code, he'd break the back end engineer. And they just couldn't figure out exactly how to separate this code and how to still leverage going full stack on C Sharp. They also struggled building a networking layer. So kind of inspired by the Akka.net project and walking away from this project and seeing their struggles, I wanted to build something that would solve those problems. And my vision was, well, what if Unity engineers could create actors with game logic from the Unity environment and then use that actor both in Unity and, deployed to, let's say, an Akka.net backend. And then I kind of refined that idea and came up with this thing I call server objects. And they look a lot like actors. They're reactive, but Unity engineers build them, on the front end, and our framework will go one, it deploys it to the back end, and two, it keeps that front end version in sync. So we handle all of the networking, and I was really happy with this project, but um, I wasn't quite sure how we would integrate it with Unity because my integration path seemed kind of dirty and overly technical, and I wasn't a like hardcore Unity engineer. So I called the best Unity engineer I've ever worked with, a guy named Dan Parker, and I showed him what I've been building, and I kind of asked him his thoughts. Well, it turned out he was working on a reactive UI system for Unity, one where he has this data store and this UI layer. And when something, you put all of your information in the data store, and when information changes, it automatically updates in the UI layer. And it's super simple to hook up UI to your data store. And I said, well, if we combine our projects, that might be something pretty special because I could take the server data that's being changed, and we could just funnel it into your data store, and then that the reactive chain will go all the way up to the UI. So basically a fully reactive stack, front to back. And we were super psyched. We decided to coordinate, and eventually we merged our projects, and we really built out this server object ecosystem. And as you will see, we took it pretty far. So here's a component diagram of what we ended up building. Um, we have we have server objects where we've created that base server object class, but the developers can go and extend that. And when they do, they automatically inherit persistence and the ability to message and the ability to kind of sync to one of those objects. And it just automatically flows into their client. And we have this piece called Syncer, and his whole job is to keep everything in sync, and he automatically updates the data store. That's that part that Dan started working on when we started working together, and that data store will automatically update the everything at the UI UX layer. So let's look through some code. This is an example of a server object. And, the first three lines are, we're giving the server object a path in the data store with an attribute. We're saying it's syncable. So some server objects can get synced to the client, and some are just supposed to be, out there in the cloud. And we're giving it a name. In this case, it's hello. And then the server object has some state. In this case, it's the greeting, what's your name? And then it has something that might look familiar, which is a handler. So here's a handler that takes a custom message. So this is completely inspired by an actor. And you'll notice that just like actors, we're going to use the name handler for every single handler, and the difference is the type of that message. And we can handle messages basically two ways. We can change our state, anything on our state, or we can send a message to another actor. So the advantages here are now Unity engineers are actually building server logic without using backend engineers, and they're allowed to run this and test it within Unity. And then once it's all working, that thing greeting is going to automatically pop into their data store, and stay in sync. And so all of the UI that uses that is going to automatically stay in sync. So we can look at the other thing we did is we made this stuff very easy to test. So one thing Unity developers really struggle with is writing test code because everything is so visual. But we came in and we said, no, there's this strict separation between visual and state. And there's a feature in Unity called Test Runner where you can run unit tests. Most Unity developers I talk to have never even seen this feature. It's like you go window general test runner, but they don't know it's there because it's just not a part of the culture, because state and UI are, generally mixed together. But with Game Plumbing Framework, there's a complete separation. So now we can test everything that's going on. So in this test, we're basically creating a syncer. So we need a syncer in order to sync stuff. And we're creating an ID. Every server object has an ID. And then we sync to it. And then we send it a message. And we can, we can do an instant send, or we can do a send wait, which means that line of code doesn't return until the server object has received and processed the message. And send wait is really helpful for testing. And then we can just use like asserts, to make sure that that all worked. Another thing we do is we make debugging super easy. So what you're looking at now is a auto-generated diagram. So let's say we created this for a game. This is one of our demo games where you can flip a coin and we have a leaderboard. So we auto-generate these diagrams that show you what's messaging what. So in this case, the client messages the coin player server object, and that messages the coin leaderboard server object. So when you have a bug, you can kind of, first you got to figure out whether it's on the server object layer or the UI layer. And you can look at our data store explorer to see all of the data that's in the data store. And if that data looks like there's something wrong with it, well, then the issue is in the server object layer. So now you can go and look at your test, you can auto-generate this diagram, and you can figure out exactly what's going wrong instead of like looking through log files. The other thing we were able to do is we took our server and we created a client version of that within Unity. So you could right click and run these tests in simulated mode as opposed to in client server mode. And that lets you put a breakpoint inside your server object, and you can like hit it from Unity and you get your full stack. Or you can, let's say you're playing your game and you hit a breakpoint and now you have the full stack all the way up to the, what happened at the UI layer. So full stack debugging is something that happens when you, take your backend and create a mock version and, bring it into the, the toolkit. We've also streamlined just the ability to add UI, right? Or to bind UI to data. So I talked a little bit about our data store, but we also have this, we've created all of these UI UI elements, components that you can actually go in, and through the inspector panel, you can basically look up everything that's in your data store. So we have global state, but we also have like an autocomplete lookup mechanism. So we've shifted a lot that used to be developers writing code to glue state to UI, and we've shifted it into like these inspectable, easy to find, this hierarchical view components where they can really quickly take that server state and visualize it. And Game Plumbing Framework keeps everything in sync. So those are just some ways that we've been able to really accelerate the development process. And right now we have two available backends. We have the Enterprise ACA one, which is far more interesting, but we also have the AWS serverless one. And we have a serverless one because that lets people get up and running and go client server basically within 10 minutes of downloading our software. But the enterprise one, we've tested it, and it's just like way easier to, way more affordable to scale, and your latency is going to be just far less, right? So we've, if you think about what is your latency for a message to the server and write back, with AWS serverless, it's 40 milliseconds plus ping. But with our enterprise Akka.NET server, it's just ping plus 5 milliseconds. So way faster, but it's even more impressive when you think about hops, like one server object or actor messaging another, because with AWS serverless, we pay that 40 milliseconds for every hop. And with our Akka, enterprise solution, we didn't actually see any significant like extra time for the hops. That might be limited testing, but that's kind of what we have observed so far. So I kind of started this out thinking, wow, Akka.net, this is such an amazing project. It could be very useful for game developers. Why isn't everybody using it? Then I kind of saw why people weren't using it. And that basically took me on a 2+ year journey to try to create something where, Unity game developers will be able to harness this power, because I really believe in this architecture and writing reactive code.
And
So yeah,
just to recap, the reason why they weren't using it was because the leap from doing stuff in Unity to doing things on the server with Akka.net required you to basically go ahead and connect all the dots together.
yeah,
Whereas you've basically shortened that journey down to something that's a lot more turnkey. Um, and basically kind of also offers things like observability and debuggability and UI integration as kind of like somewhat solved problems rather than blank sheets of paper that you have to fill in yourself.
absolutely. Yeah, we just noticed that as we put things in a framework, and we had this idea of a server object, we could take it much further. But yeah, that was the point, is to kind of connect those dots for people.
Well, that's fantastic. And I that point you make about the latency overhead of the serverless version, like its own internal communication with all these objects interacting with each other. Like
Yeah,
if you imagine, let's say, chat room object, you have one chat room object, a message gets posted to there, but then that also has to get posted to, let's say, the message state for each individual user who's subscribed to that, who might be running on all those clients. And just the internal dispatch overhead of all that decision making on the server has measurable latency with serverless. Whereas in
yeah,
Akka.net, all that messaging might be happening in memory, in which
yep,
case it's like we're talking microsecond level latency there.
yeah.
So yeah, so that's really cool. I appreciate that.
My pleasure. Yeah, I let me stop sharing, and I have a link to our we have that coin flipper game that I kind of referred to, so I
Yeah.
could put a link to that if anybody wants to um, check that out. But basically, you're flipping a coin, and you're hitting a leaderboard. And I'm happy to kind of uh, go through the code for that as well, or answer any questions. Or even auto generate the diagram like real time, whatever you're interested in.
Well, you know what I'm gonna do? I'm gonna go ahead and take over here for a second, and I'm gonna go. Actually, I'll share my screen again just so you can see. Um, go ahead and do that. Everyone who's already watching on YouTube can see my screen, but I'm gonna go ahead and play Coin Flipper. All right, so I'm here. I'm gonna go ahead and change my name here on the web. All right, I'm gonna flip a coin. Let's see. Do I need to hit enter or anything to change my name?
I think
Oh, there
if
it
you just
goes.
click out.
Yeah, I just saw an update there. All right. Well, I've got someone beating me right now. All right. Longest streak. My current streak is 1. My current streak is 0. All right, now I'm at 2. Let's see if I can get up to 3. All right, there we go. Let's take that. Flip.
Nice.
Now I'm at 4. All right. There we
Very good.
go. Okay. Now I'm back to 0 again. All right. Well, this is cool. So these are all some. So is this using the serverless version behind the scenes?
Yes,
Okay,
right now we're
cool.
using the serverless. Yeah, we
That's
we
very
haven't got
cool.
our cluster up yet.
Well, it goes to show you the value of having, let's say, like having built in, let's say, event sourcing and persistence, and the ability to go ahead and essentially have a state object you can canonically refer to, just like an actor, right?
Hmm.
That's very cool. All right, I'll go ahead and stop sharing my screen there. All right. Well, Iman, you're going to go ahead and include some, give me some YouTube links I can go ahead and embed in the show notes for this video, and we'll go ahead and refer to them at the end as well. Um,
Okay.
I really appreciate your demo, and if people want to find out more about Game Plumbing Framework or use it for their own Unity applications, where should they go ahead and get that info?
Gameplumbers.com. So I'll stick that right here.
All right.
And if you
Yeah,
go
here
to
I'm
docs.
sharing your homepage on screen here, so gameplumbers.com. I'll go ahead and drop a link to this in chat as well. All right. Sorry, I didn't mean to interrupt you. Please finish.
No, no. We also have docs.gameplumbers.com, and that has, three of these demos, just like Coin Flipper. It has, so you can play them. We have YouTube videos on basically every section in the page. So, fully documented, also with YouTube videos.
Well, great. Well, thank you very much. It's always really fun to be able to go ahead and on our community stand-ups demo someone else's work on top of Aka.net. And we really hope that you're totally successful with Game Plumbing Framework. And I'm definitely going to go ahead and take another stab at this coin flip game too when I get the chance here.